Good afternoon, everyone. I'm Midshipman First Class Andrew Shugg, and it is my pleasure to introduce this panel topic titled Force Multipliers Unlocking the Strategic Advantage of Autonomous Military Systems. As advancements in robotics and artificial intelligence accelerate, these technologies are transforming how missions are executed across every domain. From unmanned aerial and underwater vehicles to autonomous ships, ground systems, and humanoid robots, these innovations are reshaping how we gather intelligence, reduce personal risk, and expand operational reach. Today's conversation will explore how these force multipliers are revolutionizing the modern battle space, enhancing precision, efficiency, and safety while redefining the role of human operators in combat and support missions. Guiding this important discussion is Dr. Janelle Piepmeier. Dr. Piepmeier earned her Bachelor of Science in Mechanical Engineering from Latino University, followed by her Master's and PhD in the same discipline from Georgia Institute of Technology. For more than 2 decades, she has served on the faculty of the United States Naval Academy, where she has taught robotics, computer vision, and control systems to the next generation of Navy and Marine Corps officers. In 2020, Dr. Piepmeier became the 66th chair of what is now the Weapons and Robotics and Control Engineering Department. Under her leadership, the program continues to advance education and research in autonomous systems that operate on the ground, in the air, and on and below the water surface. Her research in vision-based robotic control spans both micro and macro scales, and she has published extensively on these topics. Please join me in welcoming today's moderator, an educator, researcher, and leader reshaping the future of naval robotics and autonomy, Dr. Janelle Piepmeier.
Thank you so much, Andrew, and thanks so much to the Naval Institute for putting together this event. You know, there was a joke made this morning about individuals leading a drone squadron, and I just want to say what a privilege it is for this girl to lead a team of roboticists as we're teaching midshipmen about the skills that they need to head into conflict using emerging technology. I'd like to introduce my panel. On the end, we have Dr. Kara Lapointe, Director of Analysis, Center for Security and Emerging Technology at Georgetown University. We have Admiral John Mustin, who is currently the President of Saildrone, right on my left. And then in the center, we have Mr. Michael Stewart, the former Director of the U.S. Navy's Disruptive Capabilities Office. So thank you all for joining me today. Appreciate it. I think we're going to start off talking a little bit about current roles of autonomy. And so I'd like to maybe start with Mr. Stewart. Could you address what missions or roles are most ripe today for autonomous system substitution and augmentation? And on the other side, what missions will remain firmly in the human domain for the foreseeable future?
Sure. So, well, thank you first for hosting this, and thank you, Admiral, and your staff. So let me just frame it first before I answer the question of, that was touched on this morning, is the question you want to ask yourself is, to do what? What is it you're going to do, right? So I could tell you a lot about robotic systems and AI, but what I want to answer, what I want to really frame is to do what? Why does the Navy care about this, right? And I'll tell you a sort of a quick backstory. So about 2021, the question was asked of what are we doing with unmanned, right? So we had things like LUSV, MUSV, XLUUV, which were large, complex systems. And I was asked by actually then CNO Kilday, could you take a look, or I was asked by my boss, Admiral Kilby, could you take a look at, what's the unmanned story, right? The other thing that was going on at the same time was the COCOMs and fleet commanders were concerned that we weren't moving fast enough, right? So 2027 was an imperative, and then we needed something to, in the words of the Commandant of the Marine Corps said, give me a speed bump to change Xi Jinping's decision calculus. Because right now, he's looking at our 10 shipyards, or his 10 shipyards to our 2 shipyards, and he's thinking, we're just going to outbuild them, and by 2027, they're going to be ready to invade Taiwan, okay? So the so what suddenly became, is there anything we can deliver inside 2027 to change that decision calculus? And so the second thing that was going on is if you take a look at China and Taiwan in the weapons engagement zone, I think it's pretty obvious that the Chinese have been trying to keep us out as far away from Taiwan as we can. 500 miles, 1,000 miles, 1,500 miles, 2,000 miles, right? Okay. And Admiral Paparo at the time, who was the Pacific Fleet commander, realized it was going to be a tough time to get air and sea dominance inside that weapons engagement zone, right? So all that to say is, can you move fast inside 2027 to deter the Chinese inside a weapons engagement zone? Because even if you believed in a 600-ship Navy at the time, this is 2021, if you dropped $1 trillion on the Navy, you weren't going to get the double the size of the fleet in time, right? Okay. The other thing that was going on is you saw Russia-Ukraine kick off, and what you really started to realize is that you're going to have persistent ISR. An exquisite system is not going to persist on the battlefield. You're going to get targeted immediately. You can't hide. Certainly when I was a young Navy pilot, if you're going to attack somebody, and when Greg Claros was a young Navy pilot, we'd go MCON, we'd sneak a carrier in, 500 miles, launch a strike. Those days are over, okay? So to answer your question, what are the missions you want to use? So what we realized in the Unmanned Task Force and eventually the DCO was something, I think you guys know it as hellscape, of can we use sea denial? Can we make the land between Taiwan and China impassable, right? And slow down the fleet. The Ukrainians were doing the exact same thing in the Black Sea. Can we deny the use of the Western Black Sea to the Russians, right? And right now you're seeing Task Force X in NATO answer the same question of can we deny the use of the Baltic to the Russians, specifically in Kaliningrad and St. Petersburg. So you can use unmanned systems for MDA, you can use them for kinetic effects, you can use them for logistics, but what you're probably not going to be using, you're not going to be using unmanned systems, or you're not going to use the autonomy for, is that final high critical man in the loop, super critical. Are you going to actually launch a strike, right? And then what I'll finish with is you're also using these systems right now. You know, if you index towards what the Ukrainians are doing, what Hellscape was, which is like kinetic USVs, small USVs, you're also starting to see the emergence of understanding autonomy more and more, both navigational autonomy, HM&E autonomy, to enable larger systems, the way the Navy initially envisioned things like LUSV and MUSV. Turns out those are really complex systems. So we're sort of working at this little end that will eventually enable this larger hybrid system that will complement the Navy.
Okay. Dr. LaPointe, would you like to follow up?
Sure. I think Michael really articulated, some of the missions that we've envisioned in particular. I think of this question that people ask, what are we going to use autonomy for versus what are we going to use people for? And I don't think of it that way. I'd reframe the question in terms of it's a spectrum, right? So I am literally an autonomous systems engineer, and I will tell you it is all about the people and where the humans are in the system. Now, they may be far geographically removed, right? But we're part of this larger ecosystem. And we need to be thinking about how AI and autonomy fit into our entire mission set, right? It can be in smaller ways in some applications. It can be in larger ways in other ones. So I actually had come out of the Pentagon about 5 weeks ago and went over to Georgetown, and this new lab I'm in, CSAT, part of the reason I went there is they've been doing this amazing work to really understand what the US is doing in terms of adoption of autonomous systems, but also what China is doing. And they looked at over 9,000 different kind of basically Chinese source acquisition documents to see where the PLA was experimenting with AI and autonomy. It's in everything and in every domain. And so we sometimes think of kind of the point missions that we can use AI and autonomy for, but really I think we need to be experimenting across a much larger range of domains about where we can use AI and autonomy in small or big ways.
Absolutely. Following up on that, thinking about the strategic impact, how do autonomous systems change the strategic calculus in a potential conflict with a peer adversary like China? Where do they provide real advantage, and where might they introduce risk?
Can I take that?
You can start.
No, go ahead.
Yeah. Well, so first I'll start by saying I had the good fortune to watch Michael as he transitioned from the Unmanned Task Force at the Pentagon to standing up the Disruptive Capabilities Office. So we had lots of sidebar conversations, kind of like we're going to do today in front of you. But so the first thing that I would offer about adversarial calculus is the one thing that we want to do before we even start to talk about responding to an adversary is set the theater. And so the one thing that we can do is establish persistent nodes that allow us to have maritime domain awareness. And that doesn't mean just on the water. We talk about in the water, below the water, above the water, and really from space to cyberspace as well. So, when we used to talk about domains and it was sea, air, land, now really we talk about multi-domain awareness. And drones can enable that. I mean, we're doing it today. Sail drone, this is kind of a shameless plug, but I'll talk about the ability to have hyper or ultra long duration missions 100 days at a time, or a smaller vessel for us 365 days at a time without crew or maintenance. So the opportunity to, again, set a theater where you can put things out that enable you to not only collect information, and that could be multi-sensory, that could be electronic warfare sensors and payloads, could be acoustic devices, whether that's a towed array, certainly radar, AIS, electro-optical cameras, SATCOMs, all of those things exist today. I mean, we're doing that. That's in production. But the next thing that is very interesting is the opportunity to start talking about deception operations, misinformation operations. If I can put 100 365-day mission small sail drones in the Pacific, each of which can emulate a guided missile destroyer or a carrier, then all of a sudden our adversaries have to take note, and we're imposing cost on them because they then have to react and figure out how they're going to counter. And so we heard a little bit in prior panels about how the cycle time has changed. If you look at what happened in World War I to World War II to Vietnam to the Gulf War to now, what I hear from our commander at Task Force 66 is the action, reaction, counteraction cycle is 2 weeks. So a new technique or procedure is introduced, the adversary responds to it, then we change, or we or our partners change to that response, a 2-week cycle. Now keep in mind, that is based on those of us who grew up in the late 80s or early 90s, the expectation that it would be a 6-month or 1-year cycle. So the benefit of the long-winded answer here is we can do a lot with drones and autonomy that don't require manned or crewed vessels, and they can just be there. And they can be there all the time so that if something starts, like right now, we're not at war with China, but we can certainly take the appropriate steps to either prevent or deter a war with China by exposing, whether it's conceal or reveal, some capabilities that may be interesting, but ensure that we are positioned the way that we want to be should something happen.
No, and thanks for letting me. I'm kind of biting or champing at the bit to answer this one. I love this question. So I'd go back to kind of what I said, right? So Xi Jinping is thinking, okay, this can be a cakewalk. I've just got all these shipyards. I'm producing these ships twice as fast, half the cost of the Americans. 2027, let's go. And so how do you introduce uncertainty? So you got to move really, really quickly, right? Now, thankfully, you saw the Ukrainians were actually proving out the case, but you suddenly start doing things like kinetic USVs, low munitions, small UUVs. The Chinese had spent many years trying to sort of optimize against what they thought, how they thought the Americans were going to fight. So they thought, okay, awesome, we're going to push these guys out. We're going to have a ton of satellites. We're going to have these anti-ship ballistic missiles. This is going to be a cakewalk. So what we were trying to do is introduce a ton of uncertainty. I mean, imagine if Putin had understood what was going to happen to him. So if you remember, he had a 40-mile column of tanks converging on Kyiv, and he thought he's 3 days out, this could be all over. And suddenly, asymmetrically, he got taken out. Well, bad logistics and weather, but he also got taken out with switchblades and javelins and some other stuff. The Black Sea Fleet got taken out asymmetrically, right? So now, if you're now Xi Jinping, are you really going to bet the farm on a cross-strait invasion when you've seen what happened to Putin on land? Secondly, think about Task Force 9 when we stood that up. Okay, so Admiral Cooper is the Fifth Fleet commander. He has no assets, right? So he's sitting in NAVCENT. And so if the CENTCOM commander, which he is now, if the CENTCOM commander called him up and said, can you tell me what the Iranians are doing in the Arabian Gulf or the Persian Gulf or the Indian Ocean or the Red Sea? I have no idea. Can you tell me how the Dows are resupplying the Houthis? I have no idea. What do the Iranians do? He had no assets, right? And so Task Force 9 was stood up. Hey, can we go lease things like sail drone, some USVs, stitch them together with mesh networks, use AI to start running predictive MDA, right? And the strategic effect of that was twofold. Firstly, it drove the Iranians bananas. Like, okay, what are these guys doing, right? And secondly, it changed the narrative strategically. To the Iranians were saying to the Saudis and the rest of the Arab community, the Americans actually don't care about you guys anymore. They have left town. Oh, really? We've got assets all over the place. And so I think speed of action and uncertainty and complexity can change an adversary's decision making. It's too bad that Dr. Krepin-Evans left, because his book is awesome. I read it, and it's like, I highly recommend you guys read the book, because he talks about Admiral Fisher using speed to throw off the Germans. And so I'll stop there.
Excellent points. We're talking about persistence, talking about the ability to kind of change the tempo of what's happening. But what about some of the risks that might be introduced? Dr. LaPointe, any thoughts on how autonomous systems introduce risk?
Yeah, absolutely. And I think, to the strategic advantage piece, I'm glad we're finally talking about autonomous systems as autonomous systems and not just unmanned systems, because it really is autonomy that gives you that edge, right? With that, there's also risk in it. And I know a lot of people like to talk about the ethical risk. I know there was kind of the what autonomous systems are going to do as ethical agents, right, and moral agents. But there's also a lot of work to be done in the reliability of these systems, right? And so, as we think about autonomy, working in environments where things are going to go wrong. I loved the lunchtime presentation that was talking about all the robotics that Mark was talking about, where they're trying to push over the robots, all the things that could go wrong in the environment, all the things that could go wrong, because what we have to do is we really have to put the resources in to making sure as we develop autonomy, we are thinking about the really important, kind of agentic decisions that the autonomous systems are making, but we also have to make sure we are doing all of the work to make sure these systems are robust and reliable in all different kinds of conditions, especially if we're thinking about these systems are going to operate and do things in denied environments, right? And so really ensuring that they can also be integrated into our larger system. So I think the risk is that we underestimate some of those challenges. It's not just about developing the autonomous systems themselves, but it's really about making sure that we can fully integrate them into our larger systems so that they're going to work, and they're going to work when things go wrong.
Can I piggyback on what you said?
Absolutely.
So C.N.O. Gilday actually referenced this. He said it very subtly, rules of engagement, right? So I think when I started in this space, everybody was talking about killer robots. And so you would quickly realize that I think what the general public is thinking about is you're just going to unleash some autonomous system and let it go, and a week later it comes back and tell you what you did. Well, I don't think anybody's thinking about that. And Greg Blaireau is flying around his F-18. Was not given, hey, just go fly around for 3 days and tell me what he's going to go to a kill box and do very specific sorts of things, right? So how do you bound the problem? And you don't give just total autonomy, and what are the rules of engagement, and maybe if the enemy's on that side, and you can send it to a specific place. So I think you take down the risk by making sure that the scenario you're going to put an autonomous system is very tightly bounded, and you've done a ton of sets and reps on it, but you just don't, hey, just tell me what you did, sort of thing.
One quick final point on this too. We're talking about this like it's new. And I would just tell you that Saildrone's been around for over a decade, and we've been doing this for a long time. So, we have sailed more than 2 million miles and 60,000 days. So just to put that into context, that's the equivalent of getting on a ship and steaming every single day without stopping for 164 years. So when it comes to talk about ruggedizing systems, we have worked and de-risked the ability to perform in the world's harshest environments, whether that's circumnavigating the Antarctic and the Southern Ocean. We've been up in the Bering Straits, we're in the Baltic now, we're in the Atlantic, the North, the Red Sea, the Arabian Gulf, you name it. We've been around for a long time in most of the places that the U.S. Navy cares about. But the reality is, to get back to why that's important, we've learned a ton. And our perspective has always been, get out on the water and work with sailors to figure things out. Don't wait for a requirements document from OpNav, not to throw shade on any of my OpNav peers here, but the reality is you can get an encyclopedic volume of requirements that are born in a lab or born in a conference room, as opposed to trying to make it sailor-proof by saying, let's get it on the water and see what works. And if it doesn't work, we'll iterate on it, we'll fix it. So, we're updating software. I mean, almost half of our company is software. People like to think about Saildrone as the platform, but I would just tell you, we're a data company. What we deliver to our customers, back to the use case, is the ability to see, to sense, and make sense of an environment where we as a Navy or a Coast Guard or a Border Protection Agency don't have the luxury of crewed assets. So what we can do in terms of risk is de-risk through operations. So produce and deliver. And I do chuckle somewhat when I see this is an explosive space. Everybody and their brother wakes up and says, hey, today I'm starting an autonomous company. It's great. And I laugh and say, it's going to take them 5 years to figure out how to do this. And that could be on the software side. It could be on the hardware side. One thing we know is that anything that you put on the water will break. So what's the mechanism that you've got to de-risk the mission risk? And so we've got a lot of history doing that too. But obviously it has to be addressed. And the fun part from our perspective, now back to the original comment too about whether it's sexy or not. I mean, I love to say, hey, I'm in charge of a drone company.
Right.
I know. And it's a weapons and systems grad from Navy. So anyway, more on that later.
I have a capstone group you should talk to
I'd
about
love to.
risk on the water. It's good stuff. We heard this morning they were talking about red teaming, and we've seen in the news about what our adversaries are fielding and working on. We're not the only people working in the unmanned space. What considerations are required to prepare for and successfully defend our forces from our adversaries' use of autonomous military systems? Maybe Admiral Mustin, you could start, and then Mr. Stewart, you can follow up.
So command and control obviously is foundational to not only the maximizing the utilization or value of our own systems, but also understanding our adversary systems. So when it comes to protecting our systems, first I would just say we've got rules of engagement, certainly. We've got the law of armed conflict. We understand how that works. Secretary Austin, when he was the Secretary of Defense, famously said when our boats were operating in the Arabian Gulf and Iran wanted to get a little close, he said, I don't want to go to war over an unmanned system. And so, when it comes to this, what I would say is, we have kind of the inherent right to protect our own systems and to understand how an adversary may seek to impose cost on us. Right now, our systems are commercial vessels, and they are not armed. And so I wouldn't suggest that in the future you won't see a transition to those platforms. I mean, over time, we've got 3 different size vessels, 7 meter, 10 meter, 20 meter, each of which has grown as a reflection of the complexity and the ask of our customers to say, what you do is great, could you also do this? And so we've gotten increasingly large to account for greater swap, space, weight, and power. That allows us to put more complicated sensor packages and payloads and other things on there too. That will continue. And I think what you're going to find too is, without getting into ROE about whether these are offensive and power projection assets or not, there certainly will be a day where you're going to see containerized weapons, whether that's a Mark 70 from Lockheed or something else. I mean, Saab's got a package. There's Jackal, if you know the term. There are many launchers that could fit on unmanned vessels and will very soon, as well as EW payloads and other things. So what I'm getting at is one way would be to say we can go offensive to protect ourselves or to project power. The other is we can spoof and jam and provide non-kinetic effects that also protect our own systems at the same time that we complicate adversarial calculus. But the reality is the first thing I would do, and the first thing that we expect others will do to us, is eliminate the command and control. That's the first way.
So the way I would approach this is, when I was the DCO, I had a bunch of companies come to me and say, I've got a solution. I've got directed energy, pulse energy, lasers. I've got small caliber, whatever. So there's all different things. And it was really hard to figure out which one is so what do you do, right? And then you saw the thing in the Red Sea where you're shooting SM-2s and you're taking Hornets and taking down little drones, right? And obviously a very expensive problem. One of the things that we learned in Task Force 59 was start operating with systems of systems and just not just one individual thing, but just see how they all work together, right? And you'll figure out which systems kind of work and which systems kind of don't. When Admiral Cooper was Deputy CENTCOM, I called him up and I said, why don't we Task Force 59 counter UAS? And he said, what do you mean? So I said, well, imagine if you had invited all the players, like guys like Epirus and the directed energy guys and the missile guys and guys like Anduril with their counter drones, and the Ukrainians have counter drones, all the different pedagogical approaches, right? and then figure out defense in depth, right? You're going to figure out from a really long distance, you probably want to take it out a certain way, and closer, you're going to take out a group one a different way, and you're going to see where the gaps are, and they were, by the way, in group 3, number 1. And so imagine if you had all these different systems that you could optimize their methodology, number 1. Then number 2, what you'd quickly figure out is, boy, if you had an AI engine in the back, that you were taking all this data and you're taking perception data, the AI could figure out how to engage the different thing. So I think the answer to the question is don't approach it in a different way where you can test all the different methodologies to figure out how they would all complement each other. You also have to understand, like, things on the base. Admiral Cooper asked us, hey, take a look at how to defend a naval station, Bahrain. And what we really quickly discovered is the way we were fighting a base was not the way you would fight a ship, right? So all the guys on the outskirts couldn't really talk to each other, or they had cell phones. There was not like a TAO. And you suddenly realized that this threat was really emerging much faster than it had been before. And it was almost like MAA would be checking out a shotgun, he'd check out some sort of Drake system, whatever, but it wasn't coordinated, and you were going to quickly get overwhelmed. So I think the answer to the question is, take a look at all the different methodologies, work together, figure out which one is best where, and understand that organizationally the way you're defending, especially bases, is really lagging, right? And you could do the same thing for ships. Don't shoot an SM-2 every second. Figure out that you can have defense in depth. You perhaps could have USVs way out ahead of a manned ship that are doing perception systems, or you put a missile on them or something like that. But I don't think there's any simple solution other than you've got to start doing sets and reps and figure it out. And because you can't do this, you can't sustain what you're doing now by shooting SM-2s and 6s at a drone.
For sure. As we're looking at these new emerging systems, and we need to get in sets and reps, and we need to think about them. Dr. Lapointe, I'm wondering, how do we build confidence within the force, amongst our allies, and the public, that these systems are performing reliably, ethically, and that we can think about them with trust, especially in a contested or a high-risk environment? How do we do that?
Yeah, this is really important, and we started to touch on it a little bit in the discussion earlier, right? Having the right level of confidence, so sometimes people call it justified confidence or calibrated confidence, is really important. Overconfidence in systems is dangerous, and underconfidence is also dangerous, right? And so how do you start to develop that? Well, there's a piece, that folks talked about the sets and reps and getting out there and experimenting and making sure that you are using these systems, doing it in a way that you are bringing your warfighters in, so you are developing, because you have to develop the right level of trust in the humans that are interacting with the systems, and you have to be developing the technology in a way that the trust is justified. Right? And so there's a piece of that. There's also a piece of it is figuring out, what in the autonomy and the AI, the learning-enabled systems, right? Pushing some of the science, some of the R&D forward in terms of what are the ways that we can make sure these systems work. So, for example, like formal methods, right? Formal methods is a mathematical way that in some missions, in some mission areas, you can literally start to build models and say, okay, we know in this boundary space, we'll have justified confidence in this, right? So there's a whole number of different ways that you have to keep going with the science of the actual, how you make these systems more trustworthy, especially for learning-based AI, right? Kind of machine learning and learning-based AI. You have to do the sets and reps with people. You have to bring your warfighters into the process of doing that, so you're building the confidence in that way. So it's really multimodal. You also have to figure out, how are we going to do test and evaluation of these systems? And this has been the really challenging thing, right? How do you do test and evaluation on learning-based AI when the fundamental piece of AI is nobody can explain how it works? Not even the scientists that are developing AI can explain exactly how it works inside that model, right? And so the problem is you don't know when exactly it's going to work, when exactly it's going to fail. You don't know what all those edge cases are, right? You don't know, you often don't have warning for failure, you don't have graceful degradation. Now, that could seem depressing, but there are a lot of ways to start to understand, okay, this is an operating envelope that I know these systems are going to work in, right? I have a lot of confidence in this particular operating envelope that this system is going to work. I can use these other tools and techniques from a technical perspective to grow that operating envelope. So I think that's how you have to look at it, is we know these systems are not going to work perfectly in every domain, right? Or in every situation, but starting to build the confidence about where you think it's going to work, right, and where you think it's not going to work. I have teenagers that are learning how to drive right now, right? And you see all the kids out there with the bumpers that say, "New driver." Right? I hope people don't expect my kid to drive exactly with the same amount of competence as other drivers. So what is that equivalent we can start to give to these systems? Because if we go into it with a zero defect mentality, like, oh, these systems have to work perfectly all the time or we're not going to use them, we're never going to get there, right? But can you start to say, okay, I'm really sure in this situation these systems are going to work. Pretty sure here they're not going to work, so maybe I'm not going to use it. There's this whole gray area of it may work or may not, but the risk may be worth it, because at the end of the day, it's a risk calculus. But these are the kinds of tools, both organizationally and technically, we have to develop.
Absolutely.
Can I jump in before we go to?
Yeah.
Just to say, there's certainly an operational piece as well as a production piece. So when it comes to perception, reliability, the way that we sense and make sense of the world around us, just reps and sets. Again, maybe your child is a new driver, won't be as competent as they will be 10 years from now, but having had the opportunity for us to build, for instance, the world's largest marine photo library, based on billions of images that we've taken over the years, allows our algorithms to continue to iterate and improve and optimize. So time and reps and sets is great. But also seeking classification. So if you know the American Bureau of Shipping, ABS, so we have pursued classification for each of our platforms, which is a reflection not only of the production systems, like how we're made, but also how we perform. So when we look at things like coal regs, collision avoidance, anti-collision algorithms, how we perform in maneuvering situations, that's certainly a seal of approval from a third party that says, okay, you all are you get the seal of approval from us. And we want that because we don't want to drink our own Kool-Aid. While we're pretty proud of what we've done and how we've done it, it's always helpful for someone else to come in and evaluate your homework. So again, lots to do both on the operational front, but also in how you get there. And again, this is just a differentiation between somebody that wakes up tomorrow saying, hey, I got an idea, I'm going to make an autonomous drone company. And we always say, okay, it's going to take a while. You got to figure out how it's going to work, and then you got to figure out how to make it work. So multi-layered answer there.
Right. It takes a lot of work. As I love your analogy with the new driver. It takes a lot of work to get these autonomous systems working, as we sometimes see in our lab exercises that the midshipmen are working on. All right, so let's do like a little bit of a quick round robin with each of you in terms of policy and investment priorities. If you could each prioritize like one specific investment or policy change that would accelerate autonomous capability integration across the naval force, what would that one change be?
Oh boy. Who wants to start? I mean, I would tell you right now, and this is something that Greg and I have talked about at length, centralizing the marriage between prioritization, requirements, and funding. Because right now, those are three separate, distinct stovepipes. And oftentimes, the linkage between them is not only unclear, it is Byzantine. So, I think myself as an ambassador both for the U.S. Navy, also for the Coast Guard, and also for industry would say, we would love to see tight integration between demand and delivery. And unfortunately, it just doesn't work that way. And so, if I had a magic bean to say, what could I work on right now? It would be policy support, organizational support, it would be design support to enable us as a nation or as a service to get exactly what we want from those who can provide it, like industry.
Mm-hmm.
So what I would say is, firstly, just understand where you are, right? So we're talking about disruption. So disruption is not new to industry, right? So I'll pontificate for a second, I'll answer your question. So my perception is, having been in both industry and in government, is that the U.S. Navy has not been disrupted since 1945. It was challenged, but now it's being disrupted. And what do I mean by disrupted? We are the biggest gorilla in town since 1945. So in my estimation, we've got some bad management practices, right? We spend a lot of money, we're very slow, we don't move fast, right? Awesome. So understand where that management system came from. So 1950s, early 1960s, Ford Motor Company. Think of the world at Ford Motor Company that McNamara brought to the Pentagon. So who was the competition? Not a lot, right? So get rid of risk, get rid of cost, right? And it doesn't really matter how fast you respond. I'm sure there's some guys old guys who've been around and want to punch me for that, but were you really challenged, right? Take a look at Ford Motor Company in sort of 1979. It got challenged by Nissan. Think about Boeing being disrupted by Airbus. Think about just the space companies being disrupted by SpaceX. I would say right now you're being disrupted. The Chinese are coming in twice as fast at half the cost with shipbuilding, and we've got to have management systems that have got to change. So the answer to the question is, on the left-hand side, you've got very complex log lead time, aircraft carriers, destroyers. I'm not sure you're going to change that anytime soon. On this side, you need a different sort of pedagogical approach. And you talk to the Ukrainians, they're like, you have to have this for the really super complex, but on this side, you have to recognize that you need alternative policies and organizational constructs to be able to sit there and look at commercial technology really quickly, test it, evaluate it, fund it, and then scale it if you need to. And that system does not work well in this system. And the problem is these guys have the decision rights on most of the money because they're worrying about readiness and manning and manning this stuff. And so there's no money left over. You have to understand, you have to fund and organize on the disruptive side.
And the way I think about this actually builds on what Michael just said. I worry a lot about integration at scale and at speed. People talk a lot about the innovation, but we've seen a lot of innovation. There's a lot of great systems out there. As Adam pointed out, these are not new systems. People have been working on autonomous systems for the better part of 50 years, if not longer, right? But the challenge we have is integrating at scale. So how do we do that? And so one of the challenges is we have many, many different providers still bringing systems that are full stack solutions from hardware to software that are proprietary. How do we make sure that we are focusing on getting all of these different autonomous systems, because we need them, we need a lot of them, we need them in different domains. How do we make sure they're working as part of this larger whole, right? Integrating into this complex defense ecosystem that we have. So I really think, what we need is we need a way to make sure from the autonomy perspective, we can do kind of like orchestration engineering across so that we can make sure we can get to the place where we can have a lot of different companies, a lot of different innovators bringing systems in, but they can truly plug in a very rapid way to become contributing team members in this larger system.
I think that's a perfect way to sum it up. Absolutely. I started teaching here at the Naval Academy in 1999, and at the time, we just loved robotics, as Mark Rabert said earlier, and it was a fun thing to teach. And now as I look at the landscape of what's happening out there, it's still a fun thing to teach, but it's also a really important thing to be considering. And I've thought a lot in the past year or two about, like 75, 80 years ago, what the people in my department must have been talking about in their offices and around the lunch table about, we need to start teaching radar in the classroom. We need to be changing what we're teaching in the classroom because of this new technology that's really important to our naval forces. And so conversations like this are really energizing to me as I think about the challenges ahead of us, both here at the Naval Academy and in the fleet. And I just want to thank you all so much for this really good conversation. And I'd like to open it up to the floor. As you're asking questions, please come to the mic. And as always, if a midshipman has a question, we want to prioritize you. But we'll take it here to up here in the front.
I'm Harlan Ullman. For my sins, I'm a commissioner on the Congressional Commission on the Future Navy. I find it inconceivable that the United States is going to defend Taiwan when Taiwan refuses to defend itself. It's Norway on steroids, and it could make itself impregnable. I just make that as an observation. My experience has been that too often in the Navy, we mistake tactical and operational planning for strategic planning. I do not understand the overarching strategy where autonomous vehicles fit in. You can have them, control parts of the sea. They can do all these other missions, which are really great. As George Marshall said, if you can get the objectives right, a lieutenant will write the strategy. What are the overarching strategic reasons where autonomous vehicles can or cannot play a role, realizing they have got terrific tactical operational capability? I don't understand the strategic aspects.
Interesting. would like to take that on.
So I'd love to take that on. So I mean, I would think that if you're Putin and you've seen what's happened with Ukrainians, there was going to be a cakewalk. If you could play back the tape, would he launch that thing? Will launch that invasion, because what we're trying to do is make sure Xi Jinping thinks that the calculus has changed strategically, and I'm not going to launch that. So it's a tactical effect. It's a sea denial. It's a very limited effect to make sure that Xi Jinping understands if he tries that invasion, he's going to get decimated in a way that he thought he was not going to. That if you take a look at when I was in N9I, I noticed that if this is China, this is Taiwan, and this is the West, U.S. Navy was trying to figure out how to fight inside this West, how to string a kill chain, how to tank, how to persist for a certain amount of time, and then and Xi Jinping had optimized against it. So to us, we were like, if you could launch things near Taiwan and make this an impenetrable thing, now it changes the decision calculus, because he was pretty confident that we couldn't target, we couldn't persist, and so I think that's the way I look at it.
And I would just offer that even the way you asked the question, though, is kind of boxing in autonomy as a thing, whereas I would say we have operational plans, O plans. Autonomy factors in and supports them in the same way that submarines do. So I don't think that we need to talk about the strategy for unmanned. What unmanned can offer is persistent ISR, maritime domain awareness, kinetic effect absent human interaction. And that's not the ROE thing. It's just an augmentation to magazine capacity. So it can augment the ability to deliver the O plan in the same way that any other capability would. So it's a capability augmentation as well as platform augmentation.
I'd actually think about it at an even broader level, right? So a lot of times we think about autonomous systems as augmenting here and there in different ways. We really haven't scratched the surface of what autonomy can do and how transformational it's going to be, because we have all these other challenges. We've talked about that we have to get over. But once we actually are able to innovate with disruptive autonomy and integrate it at scale and at speed, it will be transformational for how we operate, the changing character of warfare. Because we will no longer be bound, especially in the Navy side, we think about, in Department of the Navy says, we think about different domains. Like, we're very domain-centric, right? We think about each domain and how we operate. Autonomy and autonomous systems will give us an ability to operate truly cross-domain and multi-domain, right? It will give us this persistence. We talk about the persistence, but it will truly give us persistence in environments that are very challenging to get human assets, and a ubiquity that will transform how we are ultimately operating. We're not quite there, but ultimately the strategic impacts are going to be massive.
Let me just piggyback on.
Taiwan needs to have a role in its own defense.
No.
Yeah.
Got it.
I see a question on our left.
Hello. Somebody's tall. Rob Heilman. I'm with GBL Systems, which is working on the sponsorship of the Test Resource Management Center out of OSD, which I used to work for. And I'm working on a study right now looking at, TRMC is responsible for OSD oversight of DoD's test infrastructure and the test investments across the services. And I'm working on a study right now on how we prepare our test investments for disruptive technologies. And my first task in preparing for that was reading the book by the gentleman who keynoted this morning, which I just finished. It was wonderful. I also managed a number of test investments for DoD in my 30 years of DoD service. And then I managed the federal research for driverless cars for U.S. DOT, and then moved to Office of Secretary of Transportation, where Congress stood up an office because they didn't feel like there was enough expertise across DOT in what they call automation, but we call in DOD autonomy, for all things autonomy across DOT, driverless cars, drones, planes, trains, all that kind of stuff. And I was inaugural director of that, which was a term position. And I can tell you, after doing in the whole, I also had cyber for cars for the country. So after doing DOD and DOT in senior positions, I can tell you that DOD is well ahead of the other agencies, because I had a chance to work with all the other agencies. So if it makes you all feel any better, DOD is way ahead of the other agencies that I've worked with. And there is not a single regulation on the books for autonomy or cyber in vehicles in the United States. And so, which is a little terrifying for me personally. So, but my question to you guys for the study I'm working on right now, I don't know if it's more strategic or tactical, because I think there's a mixture of both. For the study that we're doing for our friends out of OSD, in performing test and evaluation on these disruptive technologies to include autonomy and AI, it's pretty tough. I've been working on it for a long time personally, right, across multiple different agencies now. So what would be your advice for this? How do we prepare DoD in test and evaluation for autonomy and AI, one of the enabling technologies for autonomy, when mostly we procure these systems as a black box, right? We don't know what's inside of these things, right? And we love repeatable, right? I was raised as a tester. I was a flight test engineer early in my career. We love repeatable, right? We love predictable. And as was stated earlier in one of the early panels, that ain't happening, right, for autonomous systems or those that are AI, and particularly those that are machine learning.
So happy to answer your question.
Go for it.
Yeah. So get your point. So I think the answer, and I'm just going to see the time is about to run out.
Go for it.
I want to make sure I can answer it. I think the answer is to make sure the testing is appropriate to the vehicle, right? I see a lot of DOT&E are presuming that you're writing a bunch of requirements and the system didn't exist. What I saw was that DOT&E was sort of getting in its own way. I'll give you an example. Admiral Gilday was sitting here, and we were trying to get a UAV to fly off a Navy ship, and all the testing was going to take forever, and no one's going to take the risk. And one day I walked in with my cell phone, and I showed him on my iPhone. I said, "Hey, I just want to show you. This is a live feed from a UAV that's flying over an Iranian Dow, and that's a live feed from a USV that's looking at an Iranian Dow, and that's coming through Starlink, through a mesh network to my Starlink." We had tried to get the Navy to go do that for years. The people who did it were actually the Coast Guard and a couple of commercial companies. So my point is, instead of holding people to a rigorous DOT&E, make sure the testing is actually appropriate to the system and you can go quickly, because the testing protocol hadn't changed at all.
If I can jump in on this one. So for 5 years at Johns Hopkins, APL, I helped lead the Institute for Assured Autonomy. We looked at this in depth. So even how you were asking the question, traditionally, test and evaluation is deterministic. You know what's going to happen with a system in all these different domains. But learning-based AI is stochastic, which means it's probability-based. It is impossible to test a stochastic system with deterministic methods, right? And so there is a philosophical and policy shift that we need to get through, so we're ever going to have a hope of saying, yes, we have the justified confidence based on the test and evaluation that we are doing in these systems to take the risk to operate in different environments. And until we make that shift, we will be stalled.
So you got to change policy?
There's policy, but it's not just policy. Right, so we had the office of the Deputy Assistant Secretary of the Navy for unmanned systems for 3 years, back in 2015. I was part of that office. We were asked to look at all RDT&E policies across the Department of the Navy to treat unmanned as unmanned. And there were many, many, many policies that had to change. It wasn't just the T&E, it was on the R&D side. Nobody wanted to put the resources in at that point to change all of them. So it's not just ultimately when you get to the testing, there's a whole number of things that you have to go back and spend the time, the resources to look at to change many policies so that we're getting to that point where we can do the T&E.
I agree, you got to change 5,000. I agree.
And one final point too is I would just tell you personally from a leadership position in a commercial company, I'm not interested in T&E anymore. I'm not interested in test and evaluation. I'm not interested in doing Task Force X anymore, which we did, an experimental task force for NATO. We did that. We're past the point where we have to prove it. We're in production in the fleets. And I'm like, you know what? It's a distraction for us to perform more tests and eval. Back to Michael's original point, which was to do what? We as a company have proved what we say we do. Our use case is validated. I just am not interested anymore. I'm like, hey, you want one boat for a week? Forget it. I've got 100 boats working for the Navy for a year. So anyway, T&E is great, but I think it's a crutch and it's an excuse to slow things down. Like, let's get out in the fleet. Let's go work.
If I can push back just a little bit on that, right? And I think we're talking about autonomy as one thing here.
Yeah.
I think we are much further along on the autonomy in terms of vehicles and kind of that platform autonomy. When it comes to mission autonomy, I think we still have a lot to figure out in terms of the T&E.
We could debate on what kind of mission. Again, we're doing a lot of missions. So anyway, there's certainly a place for more complex iterations. That's what's happening at the PAC fleet and Indo-PACOM level. But for some stuff, I mean, for what we do, for what others like us do, we are years past the point where we feel the need to continue demonstrating. We're just not doing it anymore.
Thank you.
Sorry.
Last question. Last question to Greg.
To be obedient to Ray's command to ask you a question. So, John, leader of a company, Michael, you led the Department for Disruption, and Kara, you were helping bring folks together in here. What does current naval leadership need to do? There isn't any one point of contact that you can go to get a contract signed. Government's closed, we know that is an issue. Michael, you had no resources, frankly, and you were pulling things together. And Kara, you were facing the bureaucracy and how to handle that from the standpoint of moving forward. So if we're going to unlock strategic advantage, what does leadership need to do right now in order to bring about that change, and how fast do they need to move?
We'll do like a 1 minute burn. I would just say organizationally, we need clarity. I mean, right now, there have been so many different stovepipes, some of which have been blown up, some of which have been recreated, some of which are brand new, and they're overlapping kind of Venn diagrams of authorities. I would tell you between the Secretariat, between OPNAB, between the fleets, there's a very different view of how autonomy will factor into what fleet commanders are looking for. So I would say having leadership, we'll talk about from the Secretary of the Navy or the Secretary of War, saying, here's how we're going to use it, and here's how we're going to assign authorities, which trickle down to not only requirements but funding. And that's got to be clear and concise and understood. Right now, it's not.
I would echo organizationally. We can talk about tech all day long. I think people assume if you have amazing tech, it's going to get funded. It's not, especially if it's disruptive. I always hear that culture eats whatever the expression is, eats strategy for whatever. And the assumption is that most guys in the Pentagon are sort of boneheads, and they're just they're going to slow you down because they feel like slowing you down. I don't think so. I think most guys are trying to do a good job. You have to understand the organization, what it's trying to do. I'll give you an example. Admiral Lesher, when he was the vice chief, said, why do we just not move fast? And we couldn't figure it out. What we realized is that when the crazy idea came in, it came up and then it got vetted by N96, 97, 98, very mature technologies, or very mature systems, they didn't have enough money, they were doing readiness challenges, whatever. By the time you sort of put Bondo and duct tape and sealed all the holes in the fleet, you had no money left over to do anything innovative. So you have to understand that if you're going to do something innovative, you've got to fund it, right? So two really sort of exciting things that got funded in sort of the hellscape thing. When they were funded externally, everybody's all for it, amazing. And then they came back and said, okay, now from going on, if you're going to do replicator, you guys got to fund it yourself. Dead stop, right? Because there was no funding once you actually sort of funded the Navy to do its mission. So you have to understand that that's a problem.
I agree. You need funding, you need organization, and you need to staff that organization with staff and empower. You have to develop and empower trilingual leaders who understand the technology, they understand warfighting, but they also understand acquisition. Because when you develop that cadre and empower them with money and in the right organizational construct, that is when you will start to see adoption at scale.
Awesome.
That's fantastic. Thank you all.
Well, I just want to thank Dr. Pete Meyer for moderating and doing a great job with this panel. I want to thank our panelists, another great panel. I want to thank Midshipman Shug for a great intro. Good job. We are going to recognize this panel with another Naval Institute press book, Naval Power in Action by Brent Sadler. And then we're going to do a little dance up here and excuse this panel because we have one more panel to go, and then we're just going to go right into it. So again, thanks to our panelists. Great job.